Something just pinged us from beyond the edge of everything we can see. Not from a distant star, not from another galaxy, from outside the observable universe. And NASA has no explanation. In the next 10 minutes, you're going to understand what this signal actually is, why it's physically impossible by every law of physics we have, and what it might mean for the nature of reality itself. Stay with this, all the way to the end. Before we talk about what came from beyond the universe, you need to understand what beyond the universe actually means, because most people get this wrong. When scientists say observable universe, they're not talking about all of space. They're talking about the bubble of space from which light has had enough time to reach us since the Big Bang. That bubble is about 93 billion light-years across. Everything inside it, every galaxy, every star, every black hole we've ever mapped, sits within that sphere. But here's the thing most textbooks skip over. Space doesn't end at that boundary. The universe almost certainly continues beyond what we can see. Maybe forever. We just can't observe it because the light from those regions hasn't reached us yet, and thanks to cosmic expansion, it never will. That boundary is called the cosmic horizon, and for the entirety of human history, we assumed it was a one-way wall. Information flows in. Nothing comes back from the other side. It's not a physical barrier, it's an informational one. Which is exactly why what NASA detected has broken the astrophysics community wide open. In late 2023, the James Webb Space Telescope, operating in tandem with a network of deep space radio telescopes, flagged an anomaly. A structured electromagnetic signal, not random noise, not a pulsar's rhythmic beat, something that appeared, based on its redshift signature and apparent origin vector, to be coming from beyond the cosmic horizon. That's not just unusual. That's supposed to be impossible. So what exactly did they detect? Let's get specific, because the details here are where it gets genuinely strange. The signal is what researchers are classifying as a structured radio transient. Think of it like a fast radio burst, a blip of electromagnetic energy that lasts milliseconds. But with one critical difference. Normal fast radio bursts are chaotic, loud, unstructured, like a firecracker going off in a quiet room. This signal has a pattern. It repeats at consistent intervals. The pulses are separated by a gap of approximately 4.2 seconds, and embedded within those pulses is what appears to be a sub-frequency modulation. A secondary wave riding inside the primary one. That kind of structure doesn't happen naturally in any phenomenon we've documented. Not in pulsars, not in magnetars, not in colliding neutron stars. But here's the detail that made the researchers stop cold: the signal's redshift. Every object in the universe carries a redshift signature, essentially a fingerprint of how fast it's moving away from us, which tells us how far away it is. The farther something is, the more its light stretches toward the red end of the spectrum. This signal's redshift reading is off the charts, not just distant galaxy off the charts. The numbers suggest a point of origin beyond Zathishir 1089. That's the redshift value of the cosmic microwave background, the literal afterglow of the Big Bang, the oldest light in the observable universe, sitting right at the edge of the cosmic horizon. Anything beyond that value means the source lies outside, the boundary of what is theoretically reachable by light. From our perspective, whatever sent this signal shouldn't be able to send us anything at all. And yet, let's talk about why this is so hard to explain. Because it's not just unusual, it violates something foundational. Einstein's theory of relativity gives us a universe with a speed limit. Light travels at approximately 299,792 kilometers per second, and nothing with mass can match it. But here's what's less well known. Space itself has no such limit. The universe is expanding faster than light. Regions beyond our cosmic horizon are receding from us at superluminal speeds, faster than light can cross the gap. This is why we say information from beyond the horizon can't reach us. It's not that something is blocking it. It's that the gap is growing faster than the signal can travel. It's like trying to swim upstream in a river that's accelerating away from you, for a signal to cross that boundary and reach us here. Either the laws of relativity broke down at the source, the signal traveled through something other than conventional space-time, or our understanding of the cosmic horizon is fundamentally incomplete. All three of those options are seismic. Every single one rewrites textbooks. Some physicists have proposed a fourth option, and this one is the one keeping people up at night. What if the observable universe isn't actually bounded by an empty void? What if it's bounded by another structure? A bubble wall, a brain, a region where two cosmological domains are in contact. In some models of eternal inflation, our universe is one of countless expanding bubbles, each born from a quantum fluctuation in an endless sea of inflating space. If two of those bubbles collide, or if the boundary of ours is thinner than we thought, then technically, information could bleed through. But before we get to what that might mean, and what researchers are actually saying this signal could be, you need to understand something even stranger about the instrument that caught it. The James Webb Space Telescope was already rewriting astronomy before this. Since its first images in 2022, it has found galaxies that are too massive, too mature, and too structured to exist in the early universe, according to our current models. Galaxies that look like they formed within the first 300 million years after the Big Bang, when the math says they shouldn't have had enough time to build that kind of complexity. Webb has, in essence, been quietly breaking cosmology for 2 years, and the scientific community has been scrambling to explain it. Now this. The signal was initially flagged by Webb's NIR-SPEC instrument, its near-infrared spectrograph, during a deep-field observation of a region designated JWST-UDF-7. It appeared in the data as a spectral anomaly. The team cross-referenced it against the Global Radio Telescope Array, and 3 independent observatories confirmed the same signal at the same frequency, at the same repeating interval. 3 independent confirmations. That's not a glitch. That's something real. All right, here it is. The leading hypothesis, the one that's gaining the most traction among the team who analyzed the data, is not extraterrestrial intelligence. I know that's where your brain went. Mine did too. But the scientific consensus leans elsewhere, and it's arguably more mind-bending. The signal may be evidence of a cosmological phase transition happening at the boundary of our universe. Here's what that means. In the very early universe, physicists believe space itself went through phase transitions, sudden shifts in the state of the vacuum energy underlying reality, similar to the way water suddenly snaps from liquid to ice. These transitions release enormous amounts of energy. They propagate as waves through the fabric of space-time. The current model of our universe assumes we're sitting in what's called a metastable vacuum, a state that's stable enough to sustain galaxies and life, but not necessarily the lowest possible energy state. There's a theoretical possibility, small but non-zero, that the true ground state of the universe is lower, and that somewhere out there, a bubble of that lower energy vacuum has nucleated and is expanding toward us at the speed of light. If that bubble exists at the cosmic boundary, the energy released at its leading edge could produce exactly the kind of structured, deeply red-shifted signal we're seeing. The signal could be the sound of the universe's vacuum collapsing, a phase transition wave moving through the boundary of reality. And if it's what the models suggest, it has been traveling toward us for nearly 13 billion years. We just happened to build an instrument powerful enough to hear it. Right now, in our lifetime. Let that sit for a second. Before you spiral, and you're allowed to spiral a little, let's put this in perspective. If this is a vacuum decay wavefront, it travels at the speed of light. We would never see it coming. There would be no warning, no impact, no experience of an ending. Physics would simply be different on the other side of it. But here's the reframe that actually matters right now. Whether this signal is a vacuum phase transition, a cosmic brain collision, a quantum echo from a parallel inflationary domain, or something we don't have words for yet, what it represents is a crack in the wall of the known. For the first time in human history, something from beyond the edge of everything has reached out and touched our instruments. That means the horizon isn't impenetrable. That means information can cross it. And if information can cross it, our entire model of the universe's boundaries needs to be rebuilt from the ground up. We are not sitting in a closed system. We never were. We just couldn't prove it. Until now. A signal from beyond the observable universe, a pattern that defies known physics, 3 independent confirmations, and a leading hypothesis that suggests we may be hearing the edge of reality itself, undergoing a transformation that started before Earth existed. NASA hasn't made a formal announcement yet. The paper is in peer review. But the data is real. The signal is real. And the question it's forcing physicists to ask, what lies beyond the boundary of everything we can see, is one that may reshape science for the next century. If this broke your brain a little, good. Subscribe. We drop one of these every week. Next week, the James Webb Telescope just photographed something inside a black hole's event horizon that should be physically invisible. And nobody's talking about it yet.